Hello everyone, welcome to mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 6, which is a Probability and Statistics 2 for May-June 2024, and the code is 9709/62. So please subscribe to the channel so that you will be getting the notification on the new posting of videos. Alright, so thank you. Let's move on to question number 1. Now for question number 1, a random variable x has the distribution which is Poisson distributed with lambda 145. So now A, use a suitable approximating distribution to calculate this probability. Now when you look at the lambda value, which is 145, right? So that means now here probably I'll just write x is Poisson distributed 145. That means your lambda equals to 145. That is greater than 15. Whenever it's greater than 15, that means now we have to use normal approximation. Okay, so then now for your information, for Poisson distribution, 145 is the mean and also variance. Therefore, now x is not Poisson distributed with 145 lambda, and then I will approximate it into normal. So I change to another variable. Let's say it is W, normally distributed. The mean is 145, and then the variance is also 145. Because for Poisson, the mean is same as variance. So now you need to calculate Px less equals to 150. Now be careful with this because your Poisson is discrete. Okay, it's for discrete random variable. The normal is for continuous random variable. So from discrete change to normal, we need to carry out the continuity correction factor. So 150 less equals to means that it could be 150, 149, and so on. So now we are allowed to plus minus 0.5 from 150. That means either 150.5 or 149.5. Okay, so now we have to choose the interval because the x will be changed to W. Then for the less equals sign, it will be changed to less than, because for normal distribution, for continuous distribution, equal or not equal is not important. Therefore now, to choose the interval that include the two ticks, I have to choose less than 150.5. Okay, now for your information, when your x is normally distributed with mean, mu, variance, sigma squared, the standardized normal random variable z or z equals to x minus mu over sigma. Okay, that means now here I will get P z or z less than 150.5 minus the mean is 145 over the standard deviation is square root of 145. That means now here, this is going to be P, Z, or Z less than 0.457. So, we will sketch a graph. This is a normal bell-shaped curve. This is a bell-shaped curve. So, the line is 0.457. And then the region is less than. So, this region is same as the region in the table. Therefore, just read from the table, the probability will be 0.6761. And now we round up to 3 significant figures. That is going to be 0.676. That is the solution of this question A. Now, part B, justify the use of approximating distribution in this case. So, the justification is lambda equals to 145, which is greater than 15. Okay, so this is the justification. Therefore, normal approximation. To Poisson. Question number 2, Henry wants to choose a random sample from 804 students at his college. He numbers the students from 1 to 804 and uses random numbers generated by his calculator. The first 20 random digits are produced. Okay, so given the first 20 digits, Henry's first two student numbers are 576 and 109. Okay, look at the list of 20 numbers here. 576, 109. Now A, use Henry's digits to find the numbers of the next two students in the sample. Okay, now supposedly after these two, I just continue. It's 4, 3, and then 109. But then this 109 is a repetition of the second number. Therefore, these whole 6 numbers are not chosen. Okay, so we have to continue with the next 6 numbers. So we have to choose these 6 numbers. I mean, these 2 numbers, 3-digit numbers, instead of the previous 2-digit numbers, because the 109 is repeating. So now here, my 2 numbers will be 665 and 021. Okay, now there were 30 students in Henry's sample. He asked each of them how much time, X hours, they spent on social media each week in or on average. He summarized the results as follows. So given n, summation x squared. Use this information to calculate an unbiased estimate for the mean of the x and show that the unbiased estimate for the variance is less than 0.1. Okay. Now, unbiased estimate for the mean is basically mu hat. This mu hat is the x bar. X bar is counted using summation x over n. So which is 610 over 30. And then I will be getting the answer of 20.3. Now, the unbiased estimate for variance, sigma square hat, that is S square. We use the sample variance to estimate. So S square is 1 over n minus 1 summation x squared minus square of summation x over n. This is the formula. So now my n is 30. That means this is 1 over 29. Summation x squared 12405 minus summation x is 610. Then square it over 30. Then here I will be getting 0.0575. And now you need to show that it is less than 0.1. That means this is less than 0.1. Okay, so shown. Now, Henry's friend claims that Henry has probably made a mistake in his calculation of summation x or summation x squared. Use your answer to part B to comment on this claim. Alright, mistake in his calculation. So, now, because we know that the variance, right, is less than 0.1, that means it's a very small variance. So that's why, okay, so here you just write variance is small. Therefore, or hence, Henry has probably made a mistake because the variance is too small, right? Has probably made a mistake. Right? I would say you can just write variance. Okay, so done for this question. Now, next question number 3. A student wishes to estimate the proportion P of students at her college, which has exactly one brother. She surveys a random sample of 50 students at her college and finds that 18 of them have exactly one brother. She calculates an approximate alpha % confidence interval for proportion and finds that the lower limits of the confidence interval is 0.244 correct to 3 significant figures. Find alpha correct to the nearest integer. Okay, so now basically the lower limit of alpha percent confidence interval of P, that is P hat minus Z or Z alpha over 2 square root of P hat Q hat over N. Okay, so that means now it's given 0.244. Now the P hat is probability of success. So 18 out of 50 students have exactly one brother. That is the proportion of success. So that means now here I will write 18 over 50. The minus the value, the Z alpha over 2. Then from here later I will get the alpha. Square root of 18 over 50. Okay, now you see P hat is 18 over 50. Q hat is 1 minus P hat. Therefore, you will be getting 32 over 50. Alright, so here I write 32 over 50. Then over 50, because your N is 50. So now here, I will move the second term on the right side to the left hand side to make it to positive, and move 0.244 to the other side to make it to positive. I mean to group with the constant. That means now here I will get Z or Z alpha over 2. Alright, so now when you calculate the whole fraction here, this is going to be 72 over 15625. Then you will get 18 over 50 minus 0.244. That is 29 over 250. Now, from here, my Z alpha over 2, that is 29 over 250 times square root of 15625 over 72. Okay, you just take 1 over this square root. So I will just direct swap the numerator and denominator. That means here is going to be 1.7088. Now, from the normal table, okay, so from normal table, we will just read three decimal places. 3 decimal places because of 1.788, so I read 1.709. So from table, I will write P, Z or Z less than 1.709, that is 0.9562. Now this Z alpha over 2, when you sketch a graph, is basically the line. Okay, here is 1.709. Here is 0, and the probability is 0.95. Here is 0.9562. That means now your confidence interval is basically these two parts. Okay, so here I will label this as 0.9562. So I can find this probability. So the probability which is greater than 1.709 is 1 minus 0.9562. So P 1 minus 0.9562, that is going to be 0.0438. So that means here is 0.0438. But remember, when we are constructing the confidence interval, it's actually symmetrical. That means, right, here, the middle parts we do not know. So for the left hand side, it will be the same, 0.0438. So that means now your alpha value, or alpha percentage, that is the middle part. This is your alpha percentage. So I will have to use 1 minus left and right side. So 1 minus double of 0.0438. Then since this is alpha percent, so means I have to times 100%. Okay, that means now here you will be getting 91.2%. 0.24%. And then when you refer back to the question, your alpha correct to the nearest integer, right? To the nearest integer. So means that now I will get 91%, which means my alpha is 91. Question number 4. A random variable x has the distribution normal with mean 10, variance 12. Two independent values of x denoted by x1 and x2 are chosen as random. So it means that x1 and x2 also having this distribution. Now write down the value of probability x1 is greater than x2. So p x1 greater than x2 is same as p x1 minus x2 is greater than 0. So for information, right? So x is normally distributed 10 and 12. So x1 is normally distributed with 10 and 12. x2 also same distribution. So now when x1 minus x2, so the mean you minus will be 0, but the variance you plus. So 12 plus 12, that is 24. Okay, for the variance. So now from here, which is z greater than 0 minus 0, because when you standardize, right? So x is normally distributed, mean mu, variance sigma squared. When you standardize, x minus mu over sigma. So the mu is 0. Here is also 0. End up with all 0. So when all 0, when you refer to the graph, right? Here 0. This part is 0.5 because this is symmetrical. Therefore, the question says right. So the answer is 0.5. Now part B, calculate the probability of x1 greater than 2x2 minus 3. So now I have to write px1 greater than 2x2 minus 3. I will move the 2x2 to the left side and keep the minus 3 on right side. So it will be px1 minus 2x2 greater than negative 3. So now I need to get the expression, I need to get the distribution for x1 minus 2x2. So now ex1 minus 2x2, that is ex1 minus 2ex2, because we have this formula eax plus by or minus, that is aex plus minus bey. Okay, then here I will get ex1 is 10, then ex2 is 10. Therefore, this is minus 10. Now for the variance, this is variance. Okay, we have another formula. Variance ax plus minus by. This is a squared if the a and b are the multiplication. A variance x plus, okay, plus b squared variance y. Always plus, even though it's minus. The operation plus or minus, so always plus. That means this is variance x1 plus 2 squared variance x2. So it will be 12 plus 4 times 12. So end up with 5 times 12, that is 60. Okay, so now my distribution x1 minus 2x2 is basically normally distributed with mean minus 10, variance 60. So now I get the same expression. See here? So I will refer to minus 10 and 60 as the mean and variance. So now standardize it. Z or z greater than minus 3 minus the mean over standard deviation. That means now here you will be getting p, z or z greater than minus 3 plus 10 is 7. 7 over square root 60, you get 0.904. So now sketch a graph. Once you have standardized, then you just sketch a graph. So here is 0.904 and the region is greater than. That means now from the table you are just given the region which is less than. So now it will be 1, total probability is 1 minus the previous region. So that means here is 1 minus p z less than 0.904. And now you get the probability from the table. So it will be 1 minus 0.8169, and at last you will be getting 0.1831, that is same as 0.183. So done for this question. Question 5. The number of goals scored by a sports team in the first half of any match has the distribution Poisson 3.1. The number of goals scored by the same team in the second half, just now first half. Okay, it's also Poisson but 2.4. The lambda is 2.4. You may assume that the distributions of x and y are independent. Find x less than 4. Okay, so when x less than 4, just use the distribution of x. So px less than 4. Now for your information, when it is Poisson distributed, px equals to x. This is e minus lambda to the power of x over x factorial. Then the x start from 0, 1, 2 until infinity. Okay, so less than 4, so we will write this is x equals to 0 until 3. And basically the e minus lambda is in common, right? That is a constant, so e minus 3.1, e to the power of negative 3.1. So when x goes to 0, any term with degree 0 is 0, 0 factorial, sorry, any term with degree 0 is 1, then 0 factorial is 1. That means end up with 1 here, plus 3.1 degree 1. So no need to write degree 1. 1 factorial is still 1. Then when x goes to 2, I get 3.1 squared over 2 factorial plus 3.1 degree 3 over 3 factorial. That means now here I will get the value of 0.62484. Now if I round up to 3 significant figures, I look at the 8, so it will be 0.625. B. Find the probability in a randomly chosen match. The team scores at least 5 goals. So now you have to be careful with this question because it's mentioned first half is x, second half is y. So now we are not sure whether it's x or y. So we just consider in total, right? So I let t be x plus y. So I consider any match. So it can be first half or second half. That's why I consider both sections. So now my lambda t will be the lambda x plus lambda y. That is going to be 3.1 plus 2.4. Then you will get 5.5. And now my new distribution. So t is Poisson distributed with lambda 5.5 now. At least 5 scores, at least 5 goals. So p t greater equals to 5. And as I have mentioned just now, the Poisson distribution, we do not know when to stop for the x values. So now, at least 5 means that I use the total probabilities minus all previous probabilities. So the previous probabilities is up to 4. Alright, so p t equals to 0 plus pt equals to 1 plus pt equals to 2. I have to minus all these probabilities. Pt equals to 3 and plus pt equals to 4. Because you need to calculate from 5 onwards. And just now, the e is in common. So you can factorize the e. and then consider the rest. So here I will write 1 minus E negative 5.5 because of the lambda. Then the first term is 1. Then t equals to 1 means that 5.5. pt equals to 2 means 5.5 squared over 2 factorial. Then followed by 5.5 cubed over 3 factorial. And lastly, 5.5 degree 4 over 4 factorial. Then here you will be getting 1 minus 0.357518. Then that is going to be 0.642482. And now I round up to 3 significant figures. Therefore, that is 0.642. Part C, given that the team scores a total of 5 goals in a randomly chosen match, that means this is from the T, find the probability that they score exactly 3 goals in the first half. Okay, so given that means conditional probability. So it means P, whatever you want to find, that is the first term. So exactly 3 scores in the first half, x equals to 3. Given that the total is 5. Okay, so for the conditional probability PA slash B, that is PA intersects B over PB. So from here, I will write this is basically P, x equals to 3, intersect with T equals to 5, means total is 5. That means now, if your x equals to 3 means that the y must be 2. So that total is 5. Okay, over PT equals to 5. So remember, just now your x is with Poisson distributed 3.1 and y is 2.4. So here 3.1 and then the y is 2.4. So now px equals to 3 and y equals to 2. This is since they are independent, that means this becomes px equals to 3 times. Whenever independent events for the intersection, you can just times py equals to 2 over pt equals to 5. So the t is with Poisson distributed, lambda is 5.5. Now here, px equals to 3 means that e minus 3.1, 3.1 degree 3 because x equals to 3 over 3 factorial. Then you multiply or just times e negative 2.4 because it's y. Then 2.4 with degree 2 over 2 factorial. Over pt equals to 5. Use this formula. It will be e negative 5.5, then 5.5 degree 5, okay, because t equals to 5, then over 5 factorial. So from here, the numerator, if I times, it will be 0.0584395. Then the denominator will be 0.17140068. Then now here you will get 0.34095. And now round up to to 3 significant figures. So look at the 9 here. So you round up, it will be 0.4341. Sorry, 0.341. So this is the solution of this question. Question 6. The masses of cereal boxes filled with a certain machine have mean 510 grams. An adjustment is made to the machine and an inspector wishes to test whether the mean mass of the cereal has decreased. Now after the adjustment is made, he chooses a random sample of 120 cereal boxes. The mean mass of these boxes is found to be 508. That means this is the x bar. Okay, assume that the standard deviation is 10. This is a sigma. Now test at 2% significant level whether the mean mass filled by the machine has decreased. So now here you need to check on the mean. So therefore, mu equals to 510 for the H1, and then the H naught, right? H1 is whatever your doubts, means that it is less than, because decrease, and 2%, 2.5%, so alpha equals to 0.025. Now from here, okay, the sample size is large, 120. Even though the question never mentioned normal distributed, but based on the central limit theorem, as long as the n is large, it will be approximate to normal distribution. So from here, I will refer to the normal graph. And now the region, critical region, refer to H1. So it is less than, therefore lower tail. And this region is 0.025. Now, from the normal table, you are just given the region which is on the right side. Okay, so here on the right side, and it will be towards the left side. That means here, the upper tail, the upper part, the probability is 0.025. And then the region towards the left-hand side, all this, it will be 0.975. Okay, I will label above. So here will be 0.975. So now you read the table. When the probability is 0.975, then your critical value, that is going to be 1.96. So the 1.96 is the orange, is here, 1.96. But then our actual value is the blue line. Therefore, I will label negative 1.96 because it's on the left side. Okay, so here I will write reject H naught if the Z or Z is less than negative 1.96, because this is the lower tail test. So now my calculation, I'll just do it side by side. It will be Z or Z equals to X bar minus mu over sigma over square root n. That means the X bar is given 508. The mu is at the H naught. The mu at the H naught over sigma is given 10 over square root of 120. That is the n. Then you will be getting the answer of negative 2.19, correct to 3 significant figures. Now I will mark this negative 2.19 on the region. That means it is inside. Okay, inside the region. Therefore here I will write, since the Z or Z is less than negative 1.96, so based on this rejection criteria, I need to reject H naught. This is our decision. So the conclusion, you check whether the mean mass has decreased. So since we have rejected H naught, means that there is sufficient evidence to conclude that the mean mass has decreased, right? But this conclusion is only valid for that particular alpha. So there is sufficient evidence at alpha equals to 0.025 to conclude that the mean mass of cereal boxes had decreased. Okay, so this is the conclusion for the hypothesis testing. So done for the A. Now later the inspector carries out a similar test at 2.5% different level using the same hypothesis and another 120 randomly chosen cereal boxes. Given that the mean mass is now actually 506, just now was 508. Now find the probability of type 2 error. Okay, so now let's look at the definition for type 2 error first. Probability of making type 2 error is actually probability of do not reject H naught, given that H naught is wrong. Okay, it's false. Now, I need to find out what is the value, because from the first part we know that when our x bar is 508, at last it is rejected, h naught. Okay, but then I do not know what is the actual x bar, so that is exactly negative 1.96, because as long as when you standardize it you get negative 1.96, then we need to reject h naught. So now I need to find out what is the critical value. Alright, so now from here I will just write from parts A. So critical value minus 510 over 10 over square root 120 equals to negative 1.96. Okay, and let it be critical value. Or probably I'll just let it be A lah. Let it be A. Better. So I will write A, or I write U. Okay, U minus 510 over. Okay, let me check. Okay, your mu initially 510 is not 508. Sorry. Okay, your H naught is 510. Then now, okay, so over 10 over square root 120 equals to negative 1.96. So from here I need to find out what is the U value. So your U is basically excuse me, negative 1.96 times 10 over square root plus 510. And then you will get U equals to 508.21. So now, which means, okay, so from here I will say that reject H naught if the x bar is greater equals to 508.21. Sorry, it's less, because it is the lower tail. Okay, so now here my U is the x bar now. That means now P type 2 error. So when you reject H naught, if the x bar less than 508.21, let's say this is 508, less than, you reject H naught. So if do not reject H naught, that means it must be more than. So here, do not reject H naught. Alright, so from here I will write this is basically P. The x bar is at least, you can write at least or just greater than, up to you. Here you can write equal, no problem. Okay, so because for normal distribution, since it is continuous, equal or not equal is not important. So given that H naught is false, so when H naught, you go back to the previous H naught. H naught was 510. So now it's mentioned that this H naught is false, which means basically your H naught is 506, right? So here I will write H naught equals to mu equals to 506. That's why you are given the actual H naught, the actual mu. So now again you standardize it. So it will be 508.21 minus 506 over, the rest remain, no change. So 10 over square root 120. And here is going to be P, Z or Z more than 2.421. Okay, so now sketch a graph. Once you have standardized, always sketch a graph. So here is 0. 2.421 is on the right side, and this is greater than, means the region towards right side. So it will be total probabilities 1 minus all the previous probabilities. So here I will write equals to 1 minus B Z less than 2.421, and then get the probability from the table. So this is going to be 1 minus 0.9922. So final answer 0.0078. So that's the probability of making type 2 error. Question number 7. The probability density function is given fx equals to k times 1 plus cos x, where the x is between 0 and pi, inclusive both. And then for other x, it will be 0 for the fx. So k is a constant. Now a, show that k is 1 over pi. We will use the formula, integrate from minus infinity to infinity, or probably I would say for this case, because your fx is defined from 0 to pi, so from 0 to pi, fx dx is 1. So this means total probabilities is 1. Okay, so now when I integrate from 0 to pi, since the k is constant, I will take it out. Then here 1 plus cos x dx equals to 1. Now, for your information, when you integrate cos, right, we know that differentiate sine is positive cos. So when you integrate cos, that is sine x, because integration is the reverse process of differentiation. And integrate 1 dx, that is just x. So here I get k x plus sine x. Now you are given limits, so no need to plus c. Limits from 0 to pi equals to 1. And now replace the x by pi first. So I will get k bracket pi plus sine pi minus 0 plus sine 0. That equals to 1. Now, for your information, sine 0 is 0, sine pi is 0. That means now here, I will get k times pi equals to 1. Therefore, my k is basically 1 over pi. So, we have shown this. B. Verify that the median of x lies between 0.83 and 0.84. So, verify means that you need to just replace the value, okay? Not from the definition. So, which means now, my fx, I will rewrite, instead of k brackets 1 plus cos x, now I replace my k, means that 1 over pi. And then my x is from 0 to pi. Now, we need to calculate from the probability of the x from 0 to 8.8. Sorry, the probability of x from 0 to 0.83, whether it's 0.5 or not. Because if median, the probability from the lowest to the median, it will be 0.5. Okay, so I let m be median. All right. So now I calculate. So p x from 0 to 0.83. Now, this probability is just the integration, right? 0 to 0.83 fx dx. Since we have done the integration in the previous step, which is here, so I will just replace the k and change the pi into 0.83. Okay, so my integration will be 1 over pi x plus sine x from 0 to 0.83. So now, you replace the x by 0.83, then you minus 0. Because when x equals to 0, in the previous calculation, we know that all equals to 0. Now, when you do calculation, you have to be careful, okay? Because 0.83 here, without the degree sign, that means that is radians. So now here, calculate this using radians mode. Then here, you will be getting the answer of 0.499088. So I will say that this is 0.499, correct to 3 significant figures. Now, on the other hand, we calculate this is from 0 to 0.84. So P 0 to 0.84. Okay, so just change this 0.83 to 0.84. and rewrite the rest. So here I will get 1 over pi times 0.84 plus sine 0.84, then I minus 0. So then from here, you will be getting the answer of 0.5044076. Okay, then now I round up to 3 significant figures, that is 0.504. Now, from here, I will say that px between 0 and m, right, it will be 0.5 if the m is the median. So now obviously, okay, so 0.499 is less than 0.5 and is less than 0.504. Okay, that means your m is between 0.84 and 0.83. So shown. Now see, find the exact value of ex. So I rewrite my fx. 1 over pi times by 1 plus cos x. The x from 0 to pi. So the ex is defined as integrate from 0 to pi x fx dx. So now here 1 over pi is taken out. Then now here integrate 0 to pi 1 x times 1 plus cos x. Okay, so for this integration, you have product of two terms. One is x, another one is 1 plus cos x. Therefore, I'm going to use integration by parts. So for integration by parts, because both are different functions, different types of functions, the formula is integrate u v prime or u dv dx, that is uv minus integrate v du over dx with respect to x. If you have limits ab, then you just add on the limits accordingly. This is the integration by parts. That means now my u is x. Okay, then my dv dx, it will be 1 plus cos x. So now your du dx, differentiate x with respect to x, that is 1. V is to integrate 1 plus cos x. Therefore, this is going to be x plus sine x. Now, my ex, okay, it will be 1 over pi. Then use this formula, put a bracket, uv. So, x times x plus sine x with limits 0 to pi minus integrates from 0 to pi v du dx. So, x plus sine x. So, now when we replace the values, okay, firstly, the pi. So you will get pi times pi plus sine pi minus, when x is 0, everything is 0, minus, integrate x, that will be x squared over 2. Then integrate sine x. Now, for your information, differentiate cos x. Is minus sine x. So if I integrate sine x with respect to x, the minus will move to the left side. So I get negative cos x plus c. Okay, so that means now here I should get minus, because when you integrate sine, that is minus cos. Limits from 0 to pi. Now here you will get 1 over pi okay, remember sine pi is 0. So here basically just multiply, I get pi squared. So this minus remains, right? I put a bracket. This pi, bring it in, replace first. I get pi square over 2 minus cos pi minus cos pi. Then minus, okay, put another bracket. Means I use another bracket, and then here I put square bracket. So now I replace the x by 0. So 0 minus cos 0. Okay, so when you look at here, cos pi is minus 1. Okay, cos 0 is 1. So then from here, you will be getting 1 over pi squared. Bring in the minus, so minus pi squared over 2. So the minus and minus is a plus, but then another minus, so end up with minus. So minus 1. Okay, now this minus, minus, minus. So total will be minus 1. So here I get minus 1. Okay, that means now here you will get 1 over pi. Now, pi squared minus pi squared over 2 means 1 pi squared minus half pi squared. That is half pi squared. Minus 1 minus 1, that is minus 2. So now, you have the 1 over pi there, so you can times in the 1 over pi. Right, times in. So now 1 over pi and pi squared over 2, you can simplify, it becomes pi over 2. And for the second term, it will be minus 2 over pi. Okay, so that is the exact expected value. So done for this question. Alright, so I have completed the whole paper and also comes to the end of the video. Thanks for watching. Please subscribe to the channel and share this channel with everyone, and also stay tuned for more upcoming videos. Thank you. Bye.